Hi friends, in this video we are going to discuss about the concept of series and parallel connection of resistances. Why we are going for the series and parallel connection of resistances means whenever we are going to solving the problems in the electric circuits or networks, so without knowing the series and parallel combination of resistances, it is not possible to find the a given problem solution. Okay, so that is the reason why first we need to know about how to calculate the equivalent resistance if two resistances are connected in series and two resistances are connected in parallel. So if you know about the series and parallel connection and how to calculate the total equivalent resistance when resistances are connected in series and in parallel, so if you know very well, then only it is possible to solve the problems. Okay, so that's why the concept of series and parallel connection of resistances is very important in the networks. Okay, now here, so series and parallel connection of resistances. So series and parallel combination of resistances. Okay, now see, actually we are going to discuss about the series and parallel combination of resistances. That is okay, but which type of connection we are calling as series and which type of connection we are calling as parallel? So whenever we are going to calculate the resultant of the resistances if connected in series and parallel, that is okay, but without knowing the exact series connection and without knowing the exact parallel connection of the resistances, so again it is not possible. So that is a reason why what I am doing, first I am taking two resistances. For example, so this one is the R1 resistance, and what I am doing, I am considering this is the terminal A1 and this is the terminal A2 of a resistance R1, and I am taking another resistance like this, and I am taking this is the B1 terminal of a resistance R2 and this is the B2 terminal of a resistance R2. Okay, now see here, R1, R2 both are the resistances and A1, A2 are the terminals of R1, B1, B2 are the terminals of R2. Okay, but how to identify these two are connected in series? So for that, to identify the series connection of R1 and R2, so simple. If suppose the terminal A2 of R1, if the terminal A2 of R1 is directly connected to the terminal R2 of B1, this is called as the series connection. For example, if the terminal A1 is directly connected to B1, that also series connection. For example, what? For example, so this is the R1, this one is the R2. So initially we are directly connecting these two terminals directly and we are calling as this is the series connection of R1 and R2. For example, what I am doing, if I am directly connecting this terminal to R2, then this is also series connection. Okay, for example, what I am doing, I am taking another two resistances. For example, this is R1 and this one is the R2. If suppose what I am doing, if I am going to connecting these two terminals, this connection is also called as series connection. It means what? Whenever we are going to identifying the series connection of R1 and R2, the resistance R1 terminal A1 is directly connected to B1, that is also series connection. A1 is directly connected to B2, that is also series connection. For example, A2 is connected to B2, then also that is a series connection. It means series connection means when we are going to consider the R2 and R1 resistances like this, so between these two terminals, between these two resistances, when we are going to combining these two terminals at this point, then this type of connection is called as series connection. Okay, now for example, what I am doing, I am taking three resistances. For example, I am taking three resistances. This is R1, this is R2. What I am doing, from this middle point of R1 and R2, I am taking another resistance like this. Okay, for example, this is that resistance R3. Now we can say that If suppose without placing this R3 between this R1 and R2, for example like this, then R1, R2 both are connected in series. But when we are going to connecting this R3 between this R1 and R2 like this, then in this time this both are connected, this R1 and R2 both are not connected in series. Okay, series connection means R1, R2. So for example, take one node point here. For example, if you are going to combining these two terminals at this point, then we are calling a series connection. Okay, for example, we are taking another R1, R2 and R3. For example, we are taking like this. So just observe this connection and this connection. If suppose R3 is not connected here, then R1, R2 both are in series. But by connecting this R3 here, then R1, R2 both are not connected in series. Okay, so this type of connection we are calling a series connection. Okay, so always series connection, always like this. Okay, so when we are going to see the series connection of R1 and R2, then the connection is always like this. Okay, without any disturbance from this point. For example, what I am doing, for example, another resistance I am taking, R1, R2 both are connected in series. For example, what I am doing, from this point I am connecting the R3 resistance here. Now we can say that R1, R2, R3 both are connected in series, because just observe this connection, all are connected in series. Okay, so like this we need to identify the series connection of a resistances. Okay, now coming to the actual point. Actually, what is our question? If suppose two resistances are connected in series, then how to get the equivalent resistance of the series combination of R1 and R2? So here, series connection. Okay, so series connection of R1 and R2. So here, for example, this R1 is connected like this and R2 is connected like this. Okay, between these two resistances, one node point is here, for example. So we can say that both R1, R2 both are connected in series. Now the question is, what is the resultant of these two? Okay, for example, R1 is equal to 10 ohms. For example, R2 is equal to some 30 ohms. Then how to find the equivalent? Equivalent means total resistance. Okay, the total resistance of R1, R2, if both are connected in series, means we can directly take, so total resistance RT is equal to, directly we can add these two values. It means what? R1 is 10 plus R2 is 30. Then we are going to get the total resistance is equal to 40 ohms. Okay, so like this we are going to find the total resistance of the series connection of R1 and R2. For example, another example. For example, see here. For example, this is R1, this is R2, this one is R3. For example, another resistance is connected here. This is R4. For example, this one is R5. Another resistance R6. For example, I am taking, this is the terminal 1 and this is the terminal 2. Just see here, from terminal 1 to the terminal 2, R3, R2, R1, R4, R5, R6 all are connected in series. Okay, yes or no? I already told you, if both are connected in series, mean the connection is always like this. Okay, it means these two are connected in series. So here just observe, from terminal 1 to terminal 2 all are connected in series. Now how to find the equivalent resistance of this, all the series connection of resistances, mean directly we can add all the values. It means total resistance is equal to R1 plus R2 plus R3 plus R4 plus R5 plus R6. Okay, for example, R1 is equal to 1 ohm, R2 is equal to 2 ohm, R3 is equal to 3 ohm, R4 is equal to 4 ohm, R5 is equal to 5 ohm, R6 is equal to 6 ohms, for example. Then substitute all the values here. So 1 plus 2 plus 3 plus 4 plus 5 plus 6. So here the total resistance is equal to 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, 10 plus 11. It means what? So 21 ohms is the total resistance of the series connection of all these resistances. Okay, so this type of connection we are calling as series connection. Okay, so R1, R2, R3 up to R infinity, if the connection is like this, then this type of connection we are calling as series connection. And when all the resistances are connected in series, then we can find the total resistance of the series connection of 6 resistances. We can directly find directly add all the values directly. Okay, so we can directly add all the resistances directly to get the value of total resistance like this. Okay, so this is the series connection. Now coming to the parallel connection. Okay, let's see here. So parallel connection of resistances. So parallel connection of resistances. For example, what I am doing, so here for example I am taking, this is the R1, and here for example terminal 1, and this is terminal 2. I am taking another resistance. This is terminal 1 and this is terminal 2. Just see here, this is the resistance R1, this is the resistance R2. Okay, now we can say that R1, R2 both are connected in parallel when these two are directly connected like this. Okay, so first terminal of R1, first terminal of R2 directly connected like this, and second terminal of R1, second terminal of R2 directly connected like this. Then this type of connection we are calling as parallel connection. Okay, so parallel connection. For example, sometimes for example this is the terminal, so this is the point A and this is the point B, and here for example this is the R1 and this one is the R2. So just now I told you, so for example the circuit is like this. Now see here, from this point we have terminal A and terminal B here. Okay, but just observe the connection. What I told you, the terminal 1 of R1, terminal 1 of R2 directly connected, and here the terminal 2 of R1, terminal 2 of R2 directly connected, but between this one terminal is connected like this. But we can say that we can avoid this connection here. Okay, because there is no resistance connected in this path and in this path, so that's why we can say that R1, R2 both are connected in parallel. Okay, so here in this problem both the R1 and R2 both are connected in parallel. Now the question is, when R1, R2 both are connected in parallel, then how to find the total resistance? So how to find the total resistance RT when R1, R2 both are connected in parallel? So this is very simple. Just see here, R1, R2 connected in series, then how to find the value of total resistance? By adding what? R1, R2, you will get the total resistance of the resistance. Okay, the total resistance of the series connection. For example, here R1, R2 both are connected in parallel, and we need to find the total resistance for the parallel combination. Then how to find means, always we need to consider the reciprocal. Okay, so when we are going to finding the total resistance in series connection, we are directly taking that RT is equal to R1 plus R2. This is for what? Series. This is for series. But in case of parallel, we always take reciprocal. So 1 by RT is equal to 1 by R1 plus 1 by R2. So this is for parallel. Okay. Now see here, 1 by RT is equal to 1 by R1 plus 1 by R2. Now simplify, 1 by RT is equal to, so just see, take LCM and simplify here. So here, by taking LCM, the denominator is R1, R2, and the numerator is what? R2 plus R1. Clear? Now here, 1 by RT is equal to R1 plus R2 divided by R1 into R2. This is the reciprocal of RT. Yes or no? 1 by RT is equal to R1 plus R2 divided by R1 plus R1 into R2. But we require what? Only RT. So for this, what we need to do? We need to take the reverse. So that's why RT is equal to R1 into R2 divided by R1 plus R2. Okay. So this is a procedure to calculate the value of total resistance when two resistances are connected in parallel. Okay. For example, we are going to see another example. Now, just now we discussed about when two resistances are connected in series, then how to find the total equivalent resistance. For example, if two resistances are connected in parallel, then how to find the total resistance when connected in parallel. Okay, we discussed about series and parallel combination separately. Now what I am doing, now I am going to considering both at a time. Okay, for example, what I am doing, for example, this is the resistance R1 and this is the terminal, for example, A, and here this one is R2 and here this one is R3 and here this one is, for example, R4, and for example this is the fifth resistance R5 and this is the terminal B. Okay, now see here R1, R2, R3, R4, R5. Just observe between the terminal A and between the terminal A and B, R1, R2 both are connected in series. Just observe carefully. R1, R2 both are connected in series. And here R3, R4 both are connected in parallel. So when we are going to observing the parallel connection, you have to take the dotted lines here. Okay, now see R3, R4 both are connected in parallel. It means this is the parallel combination and this R5 is individual. Okay, now see R1, R2 both are connected in series means how to find the resultant of this particular R1, R2 by directly adding these two values R1, R2. Okay, now here how to find the equivalent of this parallel combination. So here we can directly take RT is equal to product of these two resistances R4, R3 divided by R3 plus R4. Okay, we already discussed when R3, R4, when two resistances are connected in parallel, then always we need to take the reciprocal. After simplifying, we are getting the expression like this. That's why I am writing when these two R3, R4 both are connected in parallel, I am directly writing the resultant of this combination, that is RT is equal to product of R3, R4 divided by addition of R3, R4. Now this one is always R5 because this is connected in series with the combination of these two. Okay, the combination of these two. That's why now what I am doing, I am redrawing this network. Instead of, just see here, yes, now what I am doing, instead of this series connection, instead of this parallel connection, I am going to placing here directly the resultant value. For example, this is 1 ohm. For example, this is 2 ohms. And this one R1 is, for example, 1 ohm. This R4 is also 1 ohm. This R5 is equal to 1 ohm, for example. Okay. Now, R1, R2 both are connected in series means what is the resultant of these two? We are getting 2 ohms. And coming to R3, R4, R3, R4 all connected in parallel means when we are going to get the resultant of these two, so 1 into 1 divided by 1 plus 1, that will give 1 divided by 2, that is equal to 0.5 ohms. So that's why instead of this parallel combination, we are directly placing 0.5 ohms. And we know that R5 is separately connected. Okay, for example, this is the value of 1 ohm we are taken. So that's why I am directly placing the value of R5 is 1 ohm. Clear? Now see, instead of this value, we are getting 2 ohms because these two are connected in series. And here, instead of this parallel combination, we are directly placing the value of 0.5 because when these two are connected in parallel, the resultant is product of R3, R4 divided by addition of R3, R4. By substituting the value of R3, R4, we are getting 0.5 ohms. Now this 0.5 I am substituting instead of this parallel combination. And here, the R5 value is 1 ohm, that's why I am placing here. Now see, again, these three are connected in series. Okay. Now when these three are connected in series, then how to find the equivalent? Then directly we can add, yes or no? So total resistance is equal to 2 plus 0.5 plus 1. So here the total resistance is equal to 3.5 ohms. Okay. So this is the procedure we need to follow whenever we are going to solve the problems when the problem consisting of series and parallel combination of resistances. Okay,